This is our third video discussing applications of vectors. So in this video, we have a single example and it has to do with bearing. A luxury liner leaves port on a bearing of 10 degrees and travels 8.8 miles. It then turns due west and travels 2.4 miles. We want to find how far is the liner from port and what is its bearing from port. We'll round our answer to the nearest hundredth. Like always, we want to start with a good diagram. So here's port. And our liner leaves port at a bearing of 110 degrees. Remember, when you're given a single number for a bearing, you start with a due north line, and then you rotate clockwise that many degrees. So if that's 90, 110's about here. And it travels for 8.8 miles. Then it turns due west. That's perfectly horizontal this way. Try again. For 2.4 miles. And now we want to find how far the liner is from port. So we're looking for this distance here. We definitely do not have a right triangle. I know there's no proof by picture, but this is clearly no way to get into a right triangle. So that tells us we're going to be using law of sines or law of cosines here. Okay, well, I don't have enough information for either of those techniques yet. So let's exploit our diagram a little bit. We know that this red vector here at the bottom is perfectly horizontal. Well, what I'm going to do is I'm going to draw in another north line right here. So I have two north lines that are going to be parallel, cut by this blue transversal here. We know that alternate interior angles are congruent. So I'm going to extend this north line here. So that means that this right here has to be 110 degrees. Now, since our red vector is totally horizontal because that was a turn due west, that means that this right here is a 90-degree angle. That benefits us because we know then that this is only going to be 20 degrees. And now we have enough information that we can use the law of cosines to find our side x. I think I'm going to draw a breakout triangle though. I always like to have something clean to look at to actually do the computations. All right, so law of cosines. Our side x is directly across from our angle 20, so we'll start with that. X squared equals 8.8 squared plus 2.4 squared minus 2 times 8.8 times 2.4 times cosine of 20 degrees. And as I've done in previous examples and videos, I would probably just plug this all in my calculator at once, like already doing the square root, and then just know x equals the square root of all of that and just plug it into my calculator. So we are rounding to the nearest hundredth. We get our distance of x to be equal to 6.60 miles. We do need to include the 0 there because the directions asked us to round to the nearest hundredth. Next, we want to find the bearing from port. So if we're looking at port, we're standing at port, and then what is the bearing to our luxury liner? So really what we're looking for is this big angle here. I'm going to use a different color. Here we go. We want to find this big old angle there. So what we can do is, in our breakout triangle, find this angle up top. I'll call it theta. And then, that's right, that's the same as this angle here. And then we'll add it to the 110 degree bearing that we had to get our original blue vector there. And that'll give us the bearing from port to where our boat is right now. We can either use law of sines or law of cosines to find that theta. I'm going to opt to use law of sines. We know that we can use law of sines anytime we have a known pair, and our known pair this time is the 20 degree angle and the 6.60 side. Oh, sine of 20 degrees over 6.60 is going to be equal to sine of theta over 2.4. We will cross multiply 2.4 sine of 20 equals 6.60 sine of theta. Now we'll divide by 6.60, so 2.4 sine of 20 divided by 6.60 gives us sine of theta. And then to get theta, we'll just have to do inverse sine of that big fraction. We'll plug all this into our calculator, and we're rounding to the nearest hundredth. We get theta to be equal to 7.14. But remember, that's not our final answer for our bearing. Our bearing is going to be the original 110 degree bearing plus what we got for theta. So we get our final bearing to be 117.14 degrees.